Yes, good morning. And then we will through the old project to get to know the perovskite and solar cell. Okay? Yes.
Less electronics really and semiconductor things you
We have chemistry, they know, right?
So these are our two compounds that we're going to be using. So first we need to find the molar weight of them. So if you go to the periodic table, you'll find that the CS is 132.905 and Br weighs about 79.904. So that's the first thing that we're going to be doing. So we need to find the weight for the entire compound itself for both of these. So what we're going to do is simply enough is just add both of these together. We're going to take 132. Add them together. And you should get 212,809. And this is going to be grams per mole. Each one of these is 1 mole of the compound, so when we put them together it's going to be grams per mole. And then we're going to do the same thing for the second compound. So we'll take PB's weight, which is 207.2, and then we'll add it to BR, but since our compound has 2 moles of the BR, we need to use the weight of 1 BR twice, and that gives us 159.808. So that's what we're going to be using instead of just 1 mole of BR. And when you add those together, you should get 367 and just a couple decimals after it. Of DMF and 1.5 milliliters of DMSO.
Alright, today we'll be making a thin layer using the Keymat Technology spin coater. So to start off, we put our layer on the top in the middle, right here. Turn our vacuum on to secure it. Power, control, vacuum. Pick it up. Take our pipette, grab a little bit, like a drop or so, and drop a thin layer in the middle. There. So here now, we set our timer right here, 9 seconds on slow, 10 seconds fast. This one controls the speed for this. This one controls how long the speed is for this one. Then we click start. See that it starts spinning. Then we put our lid on. We just wait till it goes through. So now that it's done spinning, click vacuum, control, turn our vacuum off. Here we go. Now we have a thin layer on top of our plate. Grab it from the center. Be very careful not to touch the middle. Hands a little shaky. We got a thin layer of our substrate on there, and that's how we create it.
Alright, so what we're going to be doing now is called a UV visible scan, and we're going to be using this software in the computer, and we're basically going to take our substance that we made and insert it into the computer, and that's going to give us an observable peak of what our substance has. So the first thing we're going to do is we're going to go to setup, and we're going to go to over here, and we're going to change the beam mode to single beam and our display options to individual data. Then we'll go up here to baseline, and we'll put it on 0 baseline correlation. Hit OK, and that sets it up for these two. We're going to click on 0 just to kind of hone it in. So then we're going to insert our blank. So this one is just a blank, and this is more of a calibration for it. We'll insert it right there into the machine. And we're going to turn this one on. This is also going to help with the calibrations. So we loaded the blank. Now we're going to go right here to baseline. And it just scanned the baseline of it. So now what we're going to do, we're going to insert the sample. We're going to close this up just to be safe. And we're going to do this start, right? I'm going to start, run mainly. And so now what we can do is we can save this file and then we can go back and study it more, or we can put in more samples and we can continue to research more data and figure out what the observable piece are, which is basically going to tell us what the band gap is in our solar panel. So when we're making the material, we're trying to fine tune that band gap. This will be a great tool for us.
Remember, this will act as a solar cell. You know the solar cell? Yeah.
Like this one?
Yeah, or either. Because the solar cell has 3 layers. Not include these 2 conductive glasses. You cannot visibly see.